Welcome back. We're now going to talk about the binomial probability distribution. The binomial probability distribution is a discrete probability distribution, and a binomial experiment has 4 properties. The first property is that the experiment consists of a sequence of n identical trials. We refer to one outcome as a success and the other as a failure. The probability of success is denoted by the letter P, and it does not change from trial to trial. The probability of failure is denoted by 1 minus P, and this too doesn't change from trial to trial. For example, let us consider an experiment of tossing a coin 3 times. The experiment thus consists of 3 identical trials, and each trial consists of tossing 1 coin. There are 2 outcomes possible on each toss of a coin. You can either get a head or a tail. The probability of getting a head is P equals to 5, and the probability of getting a tail is equals to 1 minus 0.5, which is 0.5. The trials or tosses are also known to be independent because the outcome of any one trial is not affected by what happens on other trials or tosses. In Excel, we can use the binom.dist and the binom.inverse functions for calculating binomial probabilities and percentiles. Before we get started with our example in Excel, let us summarize the components that are needed for our formula. So here we need to first identify the number of trials. In this example, the number of trials is 90. The second argument that is part of our formula is the probability of success on each trial. As per this question, the probability of success is 0.7. The number of trials 90 is also known as n. And the probability of success on each trial, 0.7, is also known as p. Now let us take a look at our example here. The question reads, suppose 90 identical batteries are inserted in identical flashlights. After 7 hours of continuous use, a given battery is still operating with a probability of 0.7 or has failed with a probability of 0.3. Let X denote the number of successes in each of these 90 trials, and the success denotes the battery still functioning. Using this information, find the probabilities for the following events. So the first question here is asking us to find the probability when X is exactly 50 successes. So another way to write this is we need to find probability of X when it's equal to 50. Now we're going to make use of the binom.dist function in this example. So let's get started. We're going to start typing equal to binom. So when you see the binom.dist function, just double click on it. The first argument is asking you for numbers. This is the X value in your question. So here we're going to put 50. Now it's asking us for a trial. So the question here says that there were 90 trials. So we're going to put 90. The next argument in the question is asking us for probability -s. This is referring to the probability of success. So here, as per the question, the probability of success on each trial is 0.7, comma. So here you have 2 options, true, which is cumulative probability, and false, which is probability mass function. So here in this case, since we're looking for X when it's exactly 50, we are going to use the false statement. Let me increase the decimal place. Okay, so for when X equals to 50, our answer is going to be 0.0013. The second question is asking us for probability when it's no more than 60 successes. Here, another way to write this is probability of X when it's less than or equal to 60. So for this, we are looking at the left side of the curve all the way until 60. So let's get started with the binom.dist function. Here, Here the number x value is again 60. comma, trials is again 90, probability of success is still 0.7, and here are the two options, true and false. In the first question, when we were looking for probability when x is exactly 50, we used the false statement. But here, since we're looking at the left side of the curve all the way to 60, we're going to use the true statement because it's cumulative. If you would like to know a little bit more about the bell curve and how to interpret the probabilities, please take a look at the video that I posted before this. I'm going to insert a link right here. So here the probability of x when it's less than or equal to 60 is equals to 0.2792. Now, since probabilities are usually displayed as 4 digits, I'm going to reduce the decimal place here to 4 places. Let's move on now to the third question. So here the question is asking us to find the probability of x when it's less than 71. So again, another way to write this is probability of x when it's less than 71. So now we're going to get started with the binom dist function again. So we're going to type binom dist. And here for x, we are not going to put 71. Here, since it's looking for probability when x is less than 71, we are going to put 70. So here, in place of 71, we're going to type 70 because the question is asking us to find the probability of x when it's less than 71. Next thing is the number of trials, which is still 90. Probability of success is 0.7, and here again we are looking at cumulative probability distribution, so you're going to select the true statement. So the probability of x when it's less than 71 is 0.96. Now let's move on to question number 4. Let me label these questions. Let's move on to question number 4 here. Question number 4 is asking us to find the probability of x when it's at least 58. So here, another way to write this is we're looking at probability when x is equal to or greater than 58. Now, using the binom dist function and the true statement, we can find the probability of x until 57. Okay? Since we're looking at the right side of the curve, not the left-hand side, we need to deduct that answer from 1 because the area under the curve is equals to 1. Let us use the binom dist function to find the probability of x until 57. Okay? So here we're going to put 57. Trials is still 90. Probability of success is 0.7. And we're using cumulative, so it's going to be true. Now this probability of 0.1043 is the area on the left hand side until 57, but we need to find the probability on the right hand side, which is equal to 58 or greater than 58. So in order to find the answer to this, we're going to do 1 minus 0.1043. The probability of x when it's equal to or greater than 58 is 0.8957. Again here, the reason we deducted from 1 is because the area under the curve is equals to 1. We know that the tails go until infinity on the left hand side and the right hand side. Using the true statement and the binom dist function, we are able to find the probability of x until 57. Okay, so by deducting it from 1, we're able to find the probability on the right hand side of 58 or greater than 58. Let's move on to question number 5 now. So question 5 is asking us to find the probability of x when it's greater than 63. So another way to write this is probability of x when it's greater than 63. Okay, again we're going to apply the same technique we applied in the fourth question, because here again we're looking at probabilities on the right hand side. The only difference here is in the previous question you needed x when it was equal to or greater than 58. But in question 5, you're only looking at probabilities of x when it's greater than 63. So here, let's get started. We're going to do binom dist. Okay, so here for x, we are putting 63, not 62, because we're looking at probabilities of x when it's greater than 63, not equal to or greater than. Because of that reason, here we're going to put 63 in place of x. So n trial is still 90. Probability of success is still 0.7. And here again, we're looking at the true statement because that gives us the probabilities from the left-hand side all the way till 63. Then we're going to do 1 minus 0.5396. So the probability of x being greater than 63 is 0.4603. So let's move on to question number 6. Question number 6 is asking us to find the probability of x when it's between 55 and 65 inclusive, meaning we're looking at the probability of x when it is greater than or equal to 55 and less than or equal to 65. Now here, to make it easier, I have generated a bell curve. So for instance, this is our bell curve here. 0 is in the center. Negative values are on the left hand side and positive values are on the right hand side. So here we're looking at probability of x greater than 55, less than or equal to 65. So under the curve, if I were to draw this, 55 would be somewhere on the right hand side, let's say here. Okay. Now 65 could be somewhere again on the right hand side, around here. So we're looking at the probability of x between these 2 points. So if 55 is here, 65 is here. So we're looking at the probabilities between these 2 lines. Okay. Now we know that using the binom dist function and the true statement, we can find the probability of x until 55 and we can find the probability of x until 65. So if you take these 2 probabilities and you deduct them from one another, you will get the area in this region here. Okay. So we'll need to do the binom dist function twice. So let's get started. First, we're going to find for x when it's 55. Number of trials, 90. Probability of success, 0.7. And this is again cumulative, so the true statement. Now let's find the binom dist function for when x is 65. Trials is 90. Probability of success 0.7, and again cumulative. So taking the difference of these 2 probabilities, the probability that x is greater than or equal to 55 but less than or equal to 65 is 0.67. Let's move on to question number 7 now. Question number 7 is asking us to find the probability of x when it's exactly 30 failures. So until question number 6, we were doing the probability of success. So we included 0.7 as part of our formula. But now we're looking at the probability of failure. So the formula for probability of failure is 1 minus probability of success. Or here it's already given, so it's going to be 0.3. So this is your p, or 1 minus p. So question number 7 is asking us to find the probability of x when it's exactly 30 failures. So x equals to 30. So here we can still use the binom dist function. Now here numbers, the first number you're going to put is 30. Here for trials, we're still going to use 90 because that's the total number of trials. Now here, probability of success, we're now going to put 0.7. You can either put 1 minus 0.7 or you can directly put 0.3. So since we're looking at the probability of x when it's exactly 30, here we're using the false statement. So I'm just reducing the decimal place. So the probability of x when it is exactly 30 failures is 0.0704. Let's move on to question number 8 now. Question number 8 is asking us to find the probability of x when it is at least 33 failures. So another way to write this is to find the probability of x when it is equal to or greater than 33. So this is very similar to what we did in question number 4. So in order to find the probability of x equal to or greater than 33, we need to do 1 minus the probability of x equal to 32. So let's get started and find the binomial dist function. Let's type in 32. Number of trials is 90. Here, since we're looking at failures, we're going to type in 0.3. And again, this is your true statement. Now the second step is 1 minus 0.8957. So the probability of x equal to or greater than 33 failures is equals to 0.1043. Let's move on to question number 9. Question number 9 is asking us to find the probability of x when it is less than 40 failures. So another way to write this is probability of x when it is less than 40. So again, we can use our binomial dist function. This calculation is pretty straightforward. We're looking at when x is equals to 40, number of trials is 90. Here we're still looking at 40 failures, so we're going to use 0.3. And we're using true statement because the true statement gives us the probability all the way till 40 on the left hand side. So here the probability of x when it's less than 40 is equals to 0.9987. Now we're going to move on to the 10th question, or the last question. So here we need to find the 90th percentile of the distribution of x. So here, in order to find the 90th percentile of the distribution, we're going to use the binom.inv inverse function. So when you click on the binom inverse function, first thing it's going to ask you is the number of trials. Here, as per the question, it's 90. The second argument it's going to ask us for is probability. So here we're going to put the probability of success, which is 0.7. So the last argument is going to ask you for alpha. Alpha is basically 1 minus 0.10. So in this case, we're going to put in 0.90. So the 90th percentile of the distribution of x is equals to 69.